All right, we're going to graph two rational functions today. So for the first one that we're going to graph, example number 1, the first thing that you want to do is look at the numerator and the denominator and see if you can factor both of those. So for this, my numerator, I have the difference of two perfect squares, so I can factor that. In the denominator, I have a quadratic, so I can factor that. Once you have both the numerator and the denominator factored, you want to look at it and see if factors cancel. So do you have the same factor on the top and on the bottom? And for this function, you do. So that tells me that I'm going to have a hole in the graph of this function. So I'm just going to clean things up, write my reduced function, because for most of my pieces, I am looking at the reduced function to find them. For example, at first, we want to find the vertical asymptote. So you take the denominator of your reduced function, it's got to be the reduced function, set it equal to 0 and solve. So this is the equation of a vertical line, so it's going to read x equals. So my vertical asymptote is going to be at x equals -3. Up next, my horizontal asymptote, so you want to compare the degree of the numerator and the denominator. And you can look at the reduced function or the original, but focus on the reduced, get in the habit of that. Now, they have the same degree, so your horizontal asymptote is going to be the ratio of those leading coefficients. So 1 over 1 is 1. So I'll have a horizontal asymptote at y equals 1. It will go across. There is no slant asymptote because you only have a slant asymptote if the degree of the numerator is 1 degree larger. We know that there's going to be a hole, so a hole has an x and a y coordinate. To find the x coordinate, if you did have a factor that canceled, take that factor, set it equal to 0, and solve for x. So the x coordinate of the hole is 2. To find the y coordinate, you take that value 2, you have to plug it into the reduced function. So I'll do exactly that. I'll plug 2 in right over here to this reduced function. So in the numerator, 2 plus 2. In the denominator, 2 plus 3. So my y coordinate of the hole would be at 4/5. On the graph, when I go to graph this, I'll have an open circle. My x-intercepts, again, I'm looking at the reduced function. You set the numerator equal to 0 and solve. An x-intercept is also an ordered pair, so it has that x and the y coordinate. If you're an x-intercept, your y coordinate is always 0. So make sure you really are looking at the reduced function to find these pieces. Last, your y-intercept, plug in 0 in 4x to find that y-intercept. So if I plug in 0 plus 2 over 0 plus 3, my y-intercept is going to be at that ordered pair 0, 2/3. So now you've done all this detective work. So now you want to, piece by piece, put it on your graph. So I recommend start with your asymptotes, get those on your graph. So that's what I'm going to do next. So I'm going to put in the vertical asymptote, which is at x equals -3. When you draw your asymptotes, you want to draw them as dashed lines. And then my horizontal asymptote is at y equals 1. And now I do have some points that I can plot rather. I've got my x-intercept, so I can put that on my graph. I also have my y-intercept. And now if the coordinates that you're graphing are fractions, just approximate where they're going to be, where they're going to fall. You also have this hole, so when you graph that, you do an open circle. Now, you do want to get some additional points. So when you're finding additional points, think about your vertical asymptote as dividing your graph into parts. So I have one part and my second part. You want at least 2 points in each region. So over here, I have enough information that I can go connect the points with the curve And when I connect them, the curve will approach the asymptotes, but it's not going to cross them. Now, I don't have any points over in this region, so I'm going to find some. So I recommend I would plug in -4. That would be a great point to plug in. And then also I'll do -5 because I want 2 points in each region. You can find more, but 2 is enough. So again, I'm plugging them into that reduced function. So if I plug in -4, I'll have -4 plus 2 over -4 plus 3. And you'll simplify. And so I have a point that I can plot at -4, comma 2. And so I want an extra point. So let's plug in -5. Let's see where that will fall on our graph. And so simplifying, I have -3 over -2. So negative divided by negative. So it's about 1.5. So at -5, comma 1.5. All right, now we have enough information that we can connect our points. And as we connect them, we're going to do a smooth curve. And like I said, it's going to approach your asymptotes. So vertical asymptotes, you can never cross. And then over here, I'm going to connect the points, have them approach the vertical asymptote, and there is your rational function. So keep in mind, here is where your hole is. And so places where your function is not defined are where you have vertical asymptotes, and also if you have that hole. So if you remember from our earlier lesson, to find the domain, that's the only piece where you're looking at the original function. The domain, you look at the original function's denominator, set it equal to 0, and solve. So x cannot be -3, and it also cannot be 2. And if you think where these values are, this is the vertical asymptote, and that's the hole. For the range, you have a horizontal asymptote here where the graph will never take on this value of 1. And then you also have this hole right here where the graph will never take on the y-coordinate 4/5. So those are 2 values that are excluded from our range. All right, awesome job.